Hello once again. Okay, I'm going to give you in this video your last bit of logical structure. After that, there are no more new symbols. You've learned all of them. You just need to practice actually using them. Okay. So far, the special logical symbols you've had are the 5 truth functional connectives from TFL and the 2 quantifiers, the universal and the existential. The last bit I'm going to give you is not like that. It's a predicate. Okay, we've seen predicates before. Those are gappy sentences. They can stand for whatever you like. Any kind of predicate, like X is a mammal, X is taller than Y, whatever you want. But this time you're going to get a special predicate that always means the same thing. So it's not going to get an entry in your symbolization key. You don't get to say, here's what equals stands for, because it always stands for the same thing. Just like you don't get to say, here's what the arrow stands for. That always means if then, according to its truth table. Okay, here's the predicate. We call it identity. We symbolize it with an equal sign. I should note, the way that we write sentences using this predicate is different from other ones. So most of your predicates, you would wind up writing something like a capital letter followed by some number of lowercase letters, right? Maybe you have something like this for, so if TX stands for X is tall, and if O is a name for Obama, then TO is how you write Obama is tall. Okay. On the other hand, if I had a predicate like LXY stands for X likes Y, then I could say Obama likes Cameron by writing LOC. So in these cases, you have the capital letter for the predicate coming before the names or variables for that sentence. Identity is different. Identity, we write, you've seen equal signs before. They usually go in between two things, right? So if I want to say Clark Kent is Superman, well, I need a couple of names there. So I need, let's say C stands for Clark Kent, and maybe S officially comes from the end of the alphabet, so I can't use that. Let's use M. Let's say M is Superman. If I want to say Clark Kent is Superman, I write Z equals M, just like that. So the predicate sign here is the equal sign. It's coming in between the two names. Okay, you can handle that. So here's what that predicate means. Always, whenever you write A equals B, what you're saying is these are two names of the same object. You're saying the object A is the same thing as the object B. It doesn't have to be something like you run into with the equal sign in maths. Right? These don't have to be quantities. It doesn't have to be 2 plus 2 equals 4. I can say Clark Kent equals Superman. And what I mean there is these are the same object. Okay. A and B are the same thing, or the names A and B name the same object. If you stick around and take philosophy of mind and language with me at level 2, we will do some philosophy about what these claims are really about. If you're keen, you can look up videos on this stuff on my YouTube channel. I have a YouTube channel, that's so strange. Okay, bear this in mind. Here's why this is possible. A name, we say, always refers to the same thing. A name only refers to one thing. But one thing might be the referent of more than one name, or no name at all. So here's the picture we've got here. There's a certain person. Sometimes he wears a cape. Sometimes he wears glasses. Right. So we have the names C and, oh, why did I go away? C and M. The picture we've got here is C is the name of this person, M is also a name of that person. That's fine. When I say C equals M, I'm saying when you go look at which object, which person out in the world, the name C picks out which one the name M picks out, it's going to be the same person. Okay. Why is this useful? Here's why it's useful. Here's something you can do with the identity predicate. I said in a previous video, when you just have quantifiers and names and predicates and variables, you don't have any way of saying there's two of something, two or more. Identity lets us do that. Okay, so let's say we wanted to write this thing. We want to symbolize there are at least 2 students present. So here's a bad way of doing it. If I just write there exists an X, there exists a Y, such that X is present and Y is present. That might look like it tells me there's 2 things present, but remember what I told you about the patterns of repetition, and this is the same for variables here and for scripty letters when you're reading definitions of rules in natural deduction. When you see the same variable letter twice, that means you must put the same thing in both gaps. But when you see different letters, that does not mean that you have to put different things in the 2 gaps. It means you may put different things in the 2 gaps. So this sentence says, I can find something, call it X, and I can find something, call it Y, and I don't know, they might be different, they might be the same, such that X is present and Y is present. Well, if there's just one student present, call that student Roger, well, I can find something to put in this gap, namely a name of Roger, something to put in this gap, namely a name of Roger, and then it comes out true that Roger is present and Roger is present. So in a case where there's just one student present, this sentence is going to be true. Or think of it a different way. Suppose Clark Kent is Superman. Well, I can find one name, Clark Kent. Clark Kent is present. Let's imagine Clark Kent is out of this class. And another name, Superman. Superman is present. Clark Kent is present and Superman is present, so there's at least one thing I can put in each of these gaps, so the sentence as a whole is true. But if Clark Kent's the only person in the classroom, then I want that original English sentence to be false. So we need something else. And this is where identity helps us out. So if I want to say there are at least 2 students present, I'll still say there exists an X and there exists a Y. You're still allowed to put the same name in the X gaps and in the Y gaps. But now here's what I say about them. I say 3 things, not just 2. I say X is present, and Y is present, and it's not the case that X and Y are the same thing. So this sentence says, I can find an X and a Y such that both of them are present, and they're different from each other. That's how we say there's at least 2 students present. So if I substitute in Roger for X and Roger for Y, we wind up saying Roger is present, true, and Roger is present, true, and Roger is not the same person as Roger. Well, that's false. So I wind up with true and false, and just from the truth table, that's false. So that doesn't satisfy. In order for this sentence to be true, you need to have another person around. Here's another way of writing exactly the same thing. This is a bit of shorthand we use. You can use the not equals sign as shorthand for this thing that has a negation on it. Now bear in mind, that means, so X equals Y, that's an atomic sentence. It doesn't have any truth functional connectives in it. But X not equal to Y, that's not atomic. That's got a secret negation that you can't actually see. But we'll use this as shorthand often, just because it's easier to read. What if I want to say there are at least 3 students present? This is going to get long, this is cumbersome. Here's how I write, oh, so much. Okay, so I want to say, I can find 3 things, X, Y, and Z, such that all 3 of them are present, X is present, Y is present, Z is present. And now I have to say that each of them is different from the other 2. So X and Y are different from each other, X and Z are different from each other, Y and Z are different from each other. Okay, if I added in a 4th person, if I want to say there are at least 4 students present, I'd say X, Y, Z, and W are all present, and I have to say all of these things are different from each other, and W isn't X, and W isn't Y, and W isn't Z. If I try to say there are 5 students present, this is going to get really cumbersome really fast. But we can at least say these things. For any finite number you like, I can say there are at least that many students present with some kind of sentence in FOL, as long as I use identity. What if I want to say there are no more than 2 students present? Well, I could just say it's not the case that there are at least 3. If I want to say there are 2 or fewer, that's the same as saying there are not 3 or more. So there's me trying to persuade you of this. So I can just write, if I want to say there are at most 2 students present, I'll just take this thing and put a negation in front of it. It's not the case that all of this. Is this uninteresting? Maybe I'll just, if I want to say, yeah. But if I want to say there's exactly 1 student present, I can do that by saying there's at least 1 student present. That's just, there exists an X, Px. And there's at most 1 student present, which on the model of the previous example, we can do by saying it's not the case that there are 2 or more. There's at least 1 student present, and there's at most 1 student present. I'm actually going to leave this here for you. I want you to look at this and try to persuade yourself that this means there's at least 1 student present, and there's at most 1 student present. That's enough for now. Those are the kinds of things you can do with identity. That's what it's for. Now you know all of the logical symbols that you're going to learn in this class. Now we just need to practice using them to symbolize sentences of English, arguments from English, and practice with the tools we'll have for testing whether an argument is valid or invalid, namely natural deduction to test whether an argument is valid, and interpretations to show that an argument is invalid. My budgie is screaming for attention in the other room, so I'm going to go.